Following tables show the values of linear, quadratic, and exponential functions at various values of x. Indicate which type of function corresponds to each table. So, as we've learned, a linear function has a constant first difference, a quadratic function has a constant second difference, and an exponential function has repeated multiplication or division. Another way to put this is that a linear function has a constant difference over equal intervals, whereas an exponential function has a constant factor over equal intervals. So let's take a look. If we look at all the x values for each table, they're all just going 1, 2, 3, 4, so we don't really need to worry about the x values too much. This is plus 3, plus 3, plus 3. So constant first difference, this is linear. Seven to 14, that's plus 7, but 14 to 28 is not plus 7, so it's plus 14. 28 to 56 is plus 28. So this actually looks like it's multiplying by 2. 7 times 2 is 14. 14 times 2 is 28. 56 times 2 is 108. That would be the next one. So table B, this is exponential because it's a constant factor, multiplication or division. 6 to 9 plus 3, 9 to 14 plus 5, 14 to 21 plus 7, plus 3 plus 5 plus 7. The next number would be plus 9, because the pattern is this is going up by 2 each time. So this is the first difference. If this was constant, we'd get linear. This is the second difference. Since this is constant, that makes this a quadratic function. And lastly, D. Well, these look like the same values from B, but they're reversed. In other words, if you went up, you'd be multiplying by 2. So to go down, you're dividing by 2. So also exponential. Okay, and you'll notice this is really kind of a two-part problem. It says 29 down here, but really this is just the extension of problem 28. It's asking pick one table above and tell which table you picked, and then explain why it is the type of function you chose and why it is not each of the other two types. Explain specifically using the entries in the table. Well, this is kind of what I've been talking about as I've been explaining my answers, but they're asking for it in written form here. So I'm just going to keep it simple. I'm going to go with table A. I'm going to let them know that I'm picking table A. And I'm going to tell them that it is a linear function. And it's a linear function because it grows in equal amounts over equal intervals. And I'm just going to recreate it here so that I can be really specific about what I mean. X, Y goes 1, 2, 3, 4, 6, 9, 12, 15. Oh my goodness, you guys cannot see that. I'm so sorry. And this is going by 3. This is going by 1 each time. And to be really specific, you can see that to really show this, the thinking that's going into this is 9 minus 6 over 2 minus 1 is equal to 3 over 1. And if I did the next entry, it's also equal to 12 minus 9 over 3 minus 2. 12 minus 9 is 3. 3 minus 2 is 1 is equal to 15 minus 12 over 4 minus 3. Okay, I'm just really going into a lot of detail because they're asking me to explain specifically using entries in the table. I'm showing that these intervals on these changes in y are constant. They're all 3. And the changes in x are constant. They're all 1. So it's equal amounts over equal intervals. And then I'm going to go back to my prompt for a second here. It also asked me to explain why it's not each of the other 2 types. So to be quadratic, it would need to show a constant second difference, but it shows a constant first difference. So that's why it's not quadratic. Also, not exponential, because it doesn't grow by equal factors over equal intervals. And I'm going to give an example, like table B. And I'm going to kind of use the same math argument I made here just to show what exponential would look like by that. And so for example, if we have 14 divided by 7 over 2 minus 1 equal to 2 over 1, which is also equal to 28 divided by 14 over 3 minus 2. Okay, I don't know if this is the perfect way to show it, but what I'm showing is since this is a division, this is a factor of 2. Which is what would make this exponential, but table A is clearly linear for all of those reasons.